the reason I got into this was probably at BuzzConf, at the actual BuzzConf inner field type BuzzConf. I did indeed meet a whole bunch of people doing really interesting stuff. And one of the interesting things that was along was the NodeBot platform. And I went along with my daughter, who was 9 at the time, and we put together the NodeBot kit, and we had a bit of a play with it, and we messed about with it a bit and tried to get it to write programs in various languages. And I played with the NodeBot's JavaScript thing itself, and with various of the kind of Scratch, MIT Scratch-like languages available for that platform. But I wasn't quite happy with any of them as a platform for young kids. I think it's really important because if you want to get kids into something like programming, you have to give them as few excuses to walk away and go play Minecraft as you possibly can. And there are so many other things they could be doing, you know. So my feeling is that if you give a kid a single syntax error, or just a program does nothing, or segmentation fault core dumped, since we're in the process of talking about C code, you know, if you're handing kids that kind of thing in a classroom setting, they're going to turn them off. You know, it's going to turn people away. They're going to go, no, I don't know how to do this. I'm not a smart kid after all. I'll go do something else. And I think that's a real shame. I think once you get past that initial barrier, a lot of kids might really enjoy this. A lot of other people might not really enjoy this, but a lot of people might really enjoy this who would have been turned off earlier if they got this feeling that they weren't good at this. So I was playing around with what that might mean in terms of technologies. One of the things I really noticed with my youngest daughter, Amelia, there, the NodeBot's a relatively chunky little thing with a metal chassis. She's 5. It's an awfully big robot in a 5-year-old's hands, and it's got lots of sharp edges, and it's got lots of pointy things and headers and things like that. And she has to pick it up two-handed because it's quite big and whatever, and that really, it's very hard to pick something up two-handed and then change anything about it because it's too big to hold in one hand. And I thought, well, wouldn't it be great if we could make robots a lot smaller for primary school kids? And so at some point I went, cubic inch. And I went, no, that's ridiculous. I can't actually do that. And then I looked on eBay and discovered you can buy stepper motors that are 4 millimeters across. And I went, oh, maybe I can do that. I don't know. So I was playing around with some 3D models because we've got a whole bunch of 3D printer people here, and they're very excitable and they're sick of making tiny little rabbits. So I figured I'd come up with some 3D models and see if I can fool people into printing them for me. And little tiny stepper motors, little tiny boards, the little golden rectangle on the back there is the ESP module, with the intention of making these little spherical robots that would fit together very neatly. It'd be very hard to damage because they'd have little mud guards built into them. A lot like the kind of toys that you see kids that age playing with, balls and Lego people and all that. They're little handful-sized toys. So I was playing around with those models. I made a prototype, which is this little beast here, because you have to have a prototype at some point. It kind of sort of works, and it has googly eyes. It kind of sort of works, but it's, because it's a prototype, many times heavier than the thing that its motors are meant to be driving, so it doesn't work very well, to be fair. But you've got to start somewhere, and I think that's actually a really important lesson in itself. If you try to start off perfect, you're never going to get anywhere. So that's the prototype. And out of that, discovered that really you need some kind of actual drive gearing for stepper motors, because otherwise the thing just bounces around the place uselessly and so on and so forth. But it's kind of funny. So playing around with more sophisticated 3D modelling and so on and so forth. So it's a fun little project, and yeah, that's the end result. The eventual aim is to get to the point of having, similar to the NodeBots, like a couple of line following sensors, an ambient light sensor, some internal illumination so you can change its colour, and independent motor drives for the wheels. There's a whole syllabus of little interesting exercises you can set with just that equipment that gets kids starting from I can make the robot change colour and working up to I can make the robot follow a line and optimise that process from a very naive, harsh turning thing to a very neat university robotics level integration exercise in making it follow the line as smoothly as it possibly can. And I think that's a really interesting thing. It's to start from such a low level and get to such an advanced level with this one little tiny unit, I think is really, really exciting. So that brings me to the next part of my little project. I wasn't happy with the Scratch language family. I played around with them a little bit with my kids. It's kind of cool. Have a look at Mlebourne and all the other things. There's a long, detailed look at this on my blog as well, but I wasn't totally happy with the way those worked. I thought they had a couple of really good things going. Kids have this really instinctive understanding of the way those shapes fit together to make a program. That's really clear. But then as soon as you try to do anything more complicated, you hit variables and state and all of those things. And I think there's a few functional programming type people here who will tell you that state is the root of all evil. And variables, who needs a variable? I mean, that's just terrible. So I thought, well, let's have a look. Let's try a different model of programming. And out of the basement of, so I was just going to say, I'll go back to where I was. Out of the sort of the memory archives came this idea of data flow programming. Now, this is used by serious engineering things in things like LabVIEW. It was used in a brilliant, and I recommend you look it up, game in the Apple II era called Rocky's Boots, which is probably one of the things that taught me to program. It's a very interesting and different model of programming languages, but you can still learn a lot about problem solving from it, which is the most important bit of programming. As an aside, you hear a lot of people talking on the news. They say, oh, we've got to teach our kids to code. We've got to teach our kids to code. Coding is the least important part of a programmer's job. It's an afterthought. The most important part of a programmer's job, or just about anyone's job really, is actually working out what the problem is in the first place. And data flow programming is good at that because it gets rid of all the coding pretty much, but keeps the problem solving. Also, looking at Mlebourne and all that, there are a bunch of barriers to entry there. You have to install a whole set of software on your computer. You need a cable, you've got to plug it in, you've got to plug it out, you've got to not lose it. There are still errors you can make. You can have programs that are not valid in various ways. And the debugging is not real good. So I thought, well, let's change all of those. Let's make it web browser based. I've got this chip that talks HTTP, that's a pretty good start. We won't have any cables at all. We'll make it work over Wi-Fi. We'll get rid of coding errors because we just won't let you possibly make a wrong program. And we'll get rid of the debugging problem by not really having a separate debugger. We'll just do visual debugging right there on the screen. So what I came up with was this strange little language called Flowbot, which later turned out to be some band from like Portland or somewhere, but that's inevitable, right? There's only so many possible combinations of letters you can use, which looks a little bit like this. It has various units all connected up, and you drag and drop wires between them to connect them, very much like LabVIEW. And you can possibly see at the top of the screen there are sensors which have a little rounded top, a bit like in Scratch, to say you can't put anything on top of me. At the bottom you have actuators. And you can connect them in various logical ways and drag and drop wires between them. There's no upload or download or anything like that. When you make a change on the screen, it immediately changes the robot's behaviour straight away. There's no syntax errors. You can't connect an output to an input. Well, sorry, you can't connect an output to another output or an input to an input. And there's no typing errors. You can't connect a digital input to an analog output or vice versa. So it kind of protects you a lot from the sort of beginner mistakes that might otherwise just really make the entire process miserable. I may or may not try and do a live demo of that, depending on if I can make this work. Oh, hang on. There we go. Come back. All right, so the screen, unfortunately, is a different size than it was before, but I will try and make this into a live demo. Okay, cool. So this is basically what it looks like when you first start the thing up. Now this is actually being served, this whole web page is being served from this robot. This robot is a web server. Who knew? It's talking on Wi-Fi via my phone, which is a little perverse, but that's, I haven't quite worked out Discovery yet. That's a further problem. But we can connect up a sensor. We have a comparator that says, is this more or less than? We have variables that are really tricky to click on. We can give it a number and we can say, is this more or less than 8 centimetres, say. Now you can see on the screen there, we've got little red letters already. We're already looking at the debugger. We're always in debugging mode. And we can say, well, there's got a range sensor on the front of it. So we'll get the range sensor and it's telling us roughly how far it is until it gets a signal. I've connected that up, you can see. And you can see that the comparator now has true, false, 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 true, false. As that range changes, it's not a very good range sensor and it's seeing the table in front of it. As that range changes, you can see that the results of the comparator change. So if I put my hand in front of it, if I take my hand away from it, it kind of works. If we wire that up, to the motors, you can see that the robot starts moving. And this is where the spherical design before with the 3D printed thing that makes it really like robust and strong is actually very important all of a sudden, because they inevitably are going to end up falling off the table and breaking themselves. But if I change that and unwire something rapidly, you can see its behaviour changes instantly. There's no delay, there's no compilation step, there's no upload, there's no download, there's no fuss. It's a really low barrier to entry. And the aim here is to target this sort of system at primary school kids 5 to 10, which not entirely coincidentally is the age of my kids. And it's nice to have this whole pool of like kids you can use as lab animals with their parents' consent. So, so that's the live demo, and it kind of more or less worked. All right, so I just want to end on a little bit of a rabbit on about open source. I'm doing this whole project as open source licensed. The whole thing is MIT licensed. The hardware, there's a bunch of open hardware licenses which I haven't quite got my head around yet, and I need to read them to work out what they actually say. But the hardware designs will all be released under an open hardware license as well. Why? I mean, there are lots of people making lots of money in this industry. I wouldn't mind making lots of money in this industry. It'd be really cool. But I can't really expect people to collaborate in a project like this and not get paid. That would be a little bit crazy. There are a lot of people in this industry who know a hell of a lot about things like 3D printing or education or graphic design or very many things that I really don't know a lot about, as you can tell from looking at my live demo. I'd really love to get them involved. I'd love lots of people to get involved in this. I'd love this to be something that lots of people put some time and effort and stuff into, but I don't think it's sensible to ask people to be involved in that sort of thing unless you just right from the start say this is a public thing, this is an open thing, this is something we're all doing together. So tonight is really an invitation to people. Anyone who wants to get involved, please come talk to me. It's all live on GitHub. You can see all my terrible code getting slightly less terrible as it goes forward. You can see my terrible JavaScript. You can see my terrible C. And if you can improve it a little bit, that would be really nice.